Okay, good afternoon, everyone, and welcome to our webinar today. We'll just give it 1 or 2 minutes to allow others to join us. But you're welcome. We are glad that you could make time to join us this afternoon. So let's just allow 2 minutes max for others to join. Um, thank you. Okay, good afternoon, everyone, and thank you once again for joining us and welcome to the webinar. So the webinar is entitled From Waste Stream to Feedstock. This is about advanced recycling technologies driving cross-industry circularity. So just a background to this, the project that a team of partners from Europe and Africa are working on. And we will be presenting just some of the lessons from this Horizon Europe and some of the pilots on wood waste, textile waste, and high performance composites in the aviation sector as well, just to draw lessons from there. It's in partnership with our project, as I indicated, Wood to Wood. The Horizon project is sponsored, obviously, by the European Union. And let me just give a brief background to the project itself. So this is about advanced recycling and upcycling technologies and trying to unlock new secondary material streams. And as a background, let me read. Advanced recycling and upcycling technologies are unlocking new secondary materials, but their real value lies not just in what they recover, but in who can use what they produce and where else the same approach can work. So this session brings together EU-funded project pilots to examine how advanced recycling and upcycling technologies are generating secondary material streams that can substitute virgin feedstock across recycling, process, and manufacturing industries. So these Horizon projects and the others that are featured here in the session, they tackle different waste streams from contaminated wood waste that is taken from the construction industry demolitions to post-consumer textile waste recovered from islands. And the technologies being validated today are producing outputs that industries can actively procure and integrate with their supply chains. So equally important is the transferability question. A solution proven in one waste stream rarely stays there. So this session explores how the same technological logic, that is sorting, chemical recovery, material conversion, can be adapted across sectors, and therefore reducing the costs and the risk of adoption for industries that are looking to shift from virgin to secondary inputs. With the Circular Economy Act reshaping what compliance looks like in practice, This is a session for industries that want to understand not just what's coming, but where the feedstock opportunities actually sit. We have great presenters. In this for today's session. I will be moderating this particular session and introduce the speakers just briefly. They will talk a little bit more about themselves. And then thereafter, I will ask them to present what they have for us, and we'll have Q&A later on. Okay, thank you very much. We will start with a poll in a moment on Slido, and I'll ask my colleagues just to assist us with that. Thank you very much.
Afternoon, colleagues. You should see on your screen a poll. We would just love to understand how you would rate your existing knowledge of advanced recycling technologies in these fields. So if you can go on your cell phone or on your browser to miro.com and just type in the code for this particular poll and give us an indication using dragging the dial across of where you would put yourself in terms of your level of knowledge between very low to expert. And we'll do a similar poll at the end of the event just to see if anything has changed in your own estimation of your knowledge. Thanks very much. You can submit it as you conclude, and we should actually see the results coming up as you submit.
So Stacy, you guide me on how many we're looking for responses.
So far, we've got 13 people logged onto the Menti. 10 of them have responded. That's counting me as well. I've got to put my own responses in there.
Okay.
But yeah, the numbers are coming up. We've got 15 people logged in. Participating on the call, we've got 27 people. But I'm not sure if everybody's going to have the capacity to be responding at this moment. So if there is anyone who's having challenges getting onto the website or anything like that, do let us know in the chat and we can see if we can assist.
Fantastic. Yeah.
But so far, out of the 14 responses, you can see we've got a lot more expertise around wood and timber in this online room with us. An average of 30% in terms of rating their knowledge on wood and timber. Then textile and then aviation just at about 8%. Somebody's got more knowledge there, and that one has just gone up. We've just got an aviation expert join. But yeah, this is very useful. Thank you very much, everyone. So yeah, that's 18 respondents, Prof. If you can, if that gives you a good sense to continue, then please feel free.
Yeah, and I've noted that the numbers are going up as well.
Yeah, you can see if the actual response is there if I put my cursor over it. So you can see there are at least a couple of people who consider themselves quite high up on expertise in wood and timber recycling, and also in textile recycling. And then, as I say, we've got a couple of experts in aviation recycling as well with us today.
Great. Okay, let's give it one more minute at 12 past 1. Great. While we are receiving some more responses and it's 12 past, we'll straight away get to our presenters and panel members for this afternoon. Let me introduce Jaime Guerrero. Is working with us on the Wood2W projects, as I indicated, sponsored under the Horizon Europe project. Jaime holds a degree in chemistry from the University of Zaragoza, along with a master's degree in industrial chemistry that he obtained in 2021. His professional experience focused on the gas and chemical industries.
But it's still somebody.
Okay. Thank you for muting. Colleagues, if we could all mute. Fantastic. Great. So his professional experience focused on the gas and chemical industries. In 2021, he joined Cycle as a researcher and has been a project manager since 2025. If I miss out something, please do add, Jaime, of importance, but let's welcome Jaime.
Perfect, thank you.
Good to go first. Thank you.
Okay, so should I start sharing my screen?
Yes, please go ahead.
Okay. So I bet that you should see it in full screen mode right now. Is it correct?
It is showing, yes.
Great. Okay, so good afternoon, everyone. My name is Jaime Guerrero, currently working as an R&D project manager in CIRCE Technology Center. CIRCE is an R&D institution with more than 30 years experience in different fields all around the renewable energies, electric grids, integration of renewables, electric mobility, etc. So quite a wide span of technologies in which we are working in. And we are located in Zaragoza in Spain. So if you want to come and visit us, you are all invited. Today, I'm going to speak about our contribution in the Wood2W project, as Professor Innocent mentioned. First, let me show you some figures about it. It is a 4-year project that started in January 24, so 2 years and a half from now, time flies, and will end at the end of 2027. It is funded by the European Health and Digital Executive Agency, and its main objective is to transform different sources of wood waste into valuable resources. For instance, biocomposites that will be transformed into building materials, polyols, or personal healthcare products. It also tries to implement digital tools for improving the circular flows of secondary materials or providing adequate frameworks for construction and demolition waste valorization. So here in this slide, you can see the partners that are participating in the project, covering various categories. So universities, research centers, institutions, but also final product producers. So a big consortium of 25 partners from 10 different countries. So why did we create this Wood2W project? The construction and demolition waste is one of the largest waste streams on the planet. Europe's built environment alone generates 850 million tons of waste every year, and construction and demolition waste accounts for 1/3 of it, also generated in the European Union by volume. Within this huge volume, the wood is a significant component, which is embedded in this kind of waste and in discarded furniture. And very little of it is currently brought back into the production loop or valorized as a feedstock. So we have a resource efficiency problem and an environmental problem at the same time. That brings us to the what. The wood-to-wood takes what we call a cascade valorization approach to improve the resource efficiency and maximize the value from this waste, focused mainly on polluted wood from the industrial and urban waste. The wood is usually contaminated with paints, with resins, metal fittings, or other pollutants that traditional recycling methods struggle to handle. So instead of burning or landfilling it, in the project, we want to take it back into high-value products despite all this contamination that we can find in this kind of waste. How do we do this? We leverage the advances in sorting and separation technologies with digital tools and supporting policies to create efficient recycling and upcycling processes. You can see this reflected in the 4 pillars in the slide, which are the advanced sorting technologies, the upcycling technologies, the digital tools, and the framework creation for the policy, market, and skills. So these 4 pillars form the backbone of everything that the project does. What are the main objectives of the project? First, to produce and validate the wood-to-wood comprehensive framework or the methodology for the cascade valorization of wood waste. Secondly, we want to improve the separation capabilities in wood sorting using an adaptive sorting system based on human-robot collaboration and mixed reality technologies. Third, we want to develop these upcycling technologies, combining mechanical, chemical, bioremediation, and thermochemical processes to turn wood waste into products with the same quality as virgin created materials. Fourth is to develop digital tools for the life cycle sustainability assessment, including an LCA-based tool and a digital product passport for traceability of the products. Fifth, to validate their solutions in 3 cases that will be presented in the next slide. And sixth, to increase the competitiveness and promote sustainable practices in industry. So, we are going to take a look at the 3 use cases that are being implemented in the project. The first one is based on cascade refinement technologies, starting from this construction and demolition waste. It moves through pilot scale mock-up testing of fractionation processes to produce lignin and cellulose fiber from wood waste. The chemical and the mechanical treatments isolate different compounds, such as lignin, in solid forms for various applications. For example, we are combining them, these lignin or lignocellulose-based materials with polylactic acid to produce biocomposites, which are used to produce construction materials and panels that are being already tested. The second use case is the chemical and bioremediation technology, which treats the wood throughout the steam explosion process to remove glues and other contaminants. It also includes a fungal bioremediation to remove hazardous substances through solid-state fermentation. Finally, bio-based polyols, including non-isocyanate polyurethanes adhesives, will be synthesized from these materials. And finally, the third one, which brings us here today and which will be spoken more deeply in the next slides, is the energy and gas valorization technologies, which treats the construction and demolition wood through hydrothermal carbonization, both conventional and microwave assisted, and fluidized bed gasification to produce a gas called syngas suitable for a subsequent fermentation stage. So including a biochemical, thermochemical, and biochemical product stages. The pilot gas fermentation will produce long-chain fatty acids that will be transformed with to surfactants or personal care products. So in this slide, we can see the structure of the third use case in which we are, from CIRCE, we are collaborating together with Kiverdi and Procter & Gamble, each one focused on different stages. In the first task, CIRCE, we transform the different waste stream into syngas. Firstly, if we look to the task 11.1, we receive the liquid waste or wet wastes coming from sewage sludge or paper industry sludge, and we transform them into hydrochar because we cannot process this wet waste in a fluidized bed gasification process. The hydrochar is a carbon-rich solid and dry material, which, as I've mentioned, is more feasible to be gasified. Hydrothermal carbonization process is conducted under two approaches, a microwave-assisted heating method and a conventional heating regime. So this approach allows us to compare the composition of the product, the hydrochar, the yield from sludge to hydrochar, but also the energy and the time consumption difference between microwave and conventional heating methods. But we already achieved the same products. Then the hydrochar, together with industrial wood waste or middle density fiberboard or particle board, which is coming from furniture, are gasified in this fluid-based gasificator to produce syngas. Syngas is a gas rich in hydrogen, carbon monoxide, and carbon dioxide. But in this particular case, our approach, due to the necessities of the fermentation stage, we are aiming to maximize hydrogen and CO2 while minimizing carbon monoxide. So this is why we also want or are working to include a water gas shift system that will allow us to upgrade the composition of the syngas with the steam and the carbon monoxide present in this stream towards hydrogen and CO2. This will allow to meet or make a more feasible syngas for the next upcycling stage, which in this stage, Kiverdi will ferment the syngas in a biological assisted process to convert it into these long fatty acids that will be finally transformed, compared and validated in consumer goods by Procter & Gamble. Parallel to all these valorization schemes, we are also working on the study of the stabilization of ashes coming from biomass combustion and gasification, which are mostly rich or have important contents in heavy metals, and we are trying to stabilize them into zeolitic-like structures thanks to microwave-assisted processes. This way, we avoid or we diminish the leakages of these heavy metals and also the creation of dioxins into flows in their disposal into landfills, for example. So the main results of our work up to now are presented in the slide, where you can see the pilot fluidized bed gasifier, also in red as a response to 800 or 900 degrees of temperature. The main results include that the hydrochar produced under microwave or conventional hydrothermal carbonization show no significant differences, neither in composition or in yield, although the time and the energy consumption is 2 to 3 times lower when using microwave-assisted heating methods. So we can assess that we can confirm that we obtain the same product with less energy and less time. The yields achieved up to 50% of hydrochar produced from sewage sludge and more than 70% coming from paper and pulp industry sludge. The gasification of the hydrochar, the industrial wood waste, and the particle board is being proved feasible, with the particle board showing the greatest potential, as we have achieved up to more than 70% of hydrogen and CO2 combined prior to this water gas shift stage. So we aim to achieve almost 100% hydrogen and CO2 composition. Also, in the stabilization of the ashes, we have observed zeolitic structures that apparently diminish the leaching of heavy metals and diminish the dioxin content, but we need to confirm these results with further analytics that are currently ongoing. Regarding the fermentation of the syngas, a metabolic pathway has been engineered into this specific strain to increase the production of this C12 dodecanol. So the main target has been to produce the dodecanol, the C12 12-carbon fatty alcohols, with this modified strain cultivated on pure CO2 and hydrogen. So the next stage will try to use real syngas. However, the dodecanol production rate has not been good enough to produce the aimed surfactants, which is a comprehensive technical deviation considering the complications of the process. So therefore, the aim has shifted into the production of 16 and 18 carbon triglycerides that will be further valorized into personal care products within the facilities of Procter & Gamble. So this is mainly the work that has been conducted up to now in our use case. And finally, as the work keeps on going, we will include the commissioned water gas shift system into the gasification stage to produce an upgraded syngas stream. We will also test and upscale the fermentation of this improved quality syngas into the C18 triglycerides, and with them we will produce, test, and compare the personal care products with the conventionally produced ones. So this is all from my side. I hope that it was an interesting presentation, and if you want to keep up with us, follow us for our latest updates. Thank you very much.
Thank you so much, Jaime, for that presentation. So what we'll do, I think we'll take questions after the next two presentations. Thereafter we'll call, yeah. So let me just.
Perfect.
Thank you so much. Wonderful presentation. Our next presenter is Omar Mashi from Reboot project. It's also a Horizon Europe project. So this one provides circular solutions for sustainable tourism in the European Union islands by movable plant and co-creation with island stakeholders. So Omar holds a degree in pharmaceutical chemistry and a PhD in biochemistry. Omar brings extensive experience in textile valorization, recycling, and the use of biomaterials as technical and scientific manager at Mount Lab at Central Sport Spa. So let me invite you, Omar, to share your presentation with us.
Thank you very much, Innocent. I think that my presentation is visible now for you. And let me just thank all the organizers of this event for the opportunity to be here today to talk with all for you. So thank you again. So basically, I'm here today to give you some indication and information about the so-called Reboot solution in terms of how it's possible to convert specific feedstock into something new with a new value for the market. Reboot project started from a very simple evidence that it is this one. There are specific scenarios where the management and the valorization of waste is not so easy. In particular, we're talking about islands. In islands, with the touristic purposes, of course, we have an inhomogeneous and not predictable generation of waste that basically is related to the presence of tourists. And as you can see in this slide on the left, there is an indication of the tourists that visit specific area, and that is Corfu in Greece. So we have a generation of waste that is not homogeneous and constant along the year. The island usually have problems in the installation of facilities for the waste management due to reduced space on the island, and of course also due to the distance from the mainland. So basically there is a difficulty in the management of waste that usually requires the transportation to the mainland with a lot of cost, of course, but also impacts related to the transportation. So we started with Rebot 1.5 years ago, and here you can see the partnership of Rebot that is coordinated by the university, the Politecnico of Milan, so an Italian university, and as you can see, we have representation from different European countries, and in particular we have Greece and Italy that are the most involved partners and countries when talking about the future application of the Rebot solution during the project. It is a 3.5-year long project funded under Horizon Europe, and basically what we want to do in Rebot is to create, to develop, and to validate a different, let me say, model for waste valorization. We're talking about something that is decentralized, that is portable, that is local, that can allow us to exploit the waste, the feedstock collected in specific scenarios of the island in order to transform them locally with a strong involvement of the local stakeholders, so small companies, so designers, artisans, cities, and why not also tourists. So we are not talking about a conventional application of the technology that is well known in terms of technology when we're talking about recycling, for example, of textile waste. So we are just adapting the technology in a different scenarios that we will demonstrate in the future months of the project, of course, that there's a scenario, there's atypical scenarios can be considered a potential source of feedstock that can be valorized through the recycling approach. Basically, we wanted to create a sort of local and decentralized facility for the conversion, transformation of different kind of waste stream. Of course, I'm coming from Centrocot, that is a company that is active in textile. So I will going to show you what we are doing in terms of textile revalorization, textile waste revalorization. And the idea is to bring technologies that are already demonstrated at industrial level, but to transfer them into a smaller scenario, a local and decentralized scenario of recycling. And again, one of the strongest point that was very appreciated by European Commission during the evaluation of the report project is the idea to have a strong involvement of not so typical stakeholders. So we're talking about very small local companies, we are talking about artisans, we are talking about designers and so on. The idea is to have their involvement also to increase their awareness, to increase their commitment, to increase their understanding of the potential of how the technology that we can put on the table can help them to locally transform their waste that now represent a problem in something that can represent an opportunity, a value. So basically we started with conventional technology, and the first step when you want to recycle something, you know, basically is the preparation for recycling. And one of the steps of the preparation for recycling is the sorting. So the ability to separate, to identify and then separate a waste that is in a form of an homogeneous batch in different homogeneous batch. We're talking about textile. As you can see on the top right of the slide, we have different material that we collect and hopefully transform into a new product. We will have different waste, but of course now I'm talking about textile. So basically in the first step of Rebot, we will basically work with 3 different categories: synthetic fibers, so including polyester, polyamide, polypropylene, cellulosic fibers, in particular cotton, and then the most representative, let me say, blend of textile that is represented by the so-called polycotton, so blends of polyester and the cotton that we can find on the market in a very huge volume, and so they become waste, basically. The idea is to start with sorting technology that already in the industrial level basically is based on the use of near-infrared, of hyperspectral imaging, on visual imaging. The idea is to combine them different technology and elaborate the signals that the different technology, so as you can see in the bottom left, the spectral signals for the composition mapping on a single sample, the near infrared for the identification of, in our case, of course, the fiber composition to discriminate cotton or better cellulose from polyester and polyamide and so on. And then the visual imaging in order to identify which kind of item I'm working on, combine the different signals with the support of an artificial intelligence-based tools in order to elaborate the different signals in order to have a single identification of material. For example, this item is a plastic bottle made by PET. This other object is still PET, but it is a t-shirt. And you can imagine that from a recycling point of view, a t-shirt or a plastic bottle, even if they are composed by the same chemical, so basically PET, they have to be treated in different ways because one item is a t-shirt, so a piece of fabric, one other is a plastic bottle. So completely different from the recycling point of view, at least for the technology that we are going to use in Robot. And this is the technology. We are not let me say, developing new technology. We are using technology that are already on the market. Here you can see a very small scale spinning facility starting from the frying. So the process that transform a piece of fabric or a piece of clothing into a mass of fibers that can be transformed by carding into a veil, then into a sliver, then a roving, and finally into a yarn. And that yarn will be used for weaving. And all of these steps, all these processes will be done locally, directly in the pilot site, so in the island of Corfu or in the island of Lipari for the robot application. Basically, we will have different containers that will be optimized and customized in order to allocate, to host, the different technologies, and these containers will be moved in the different location where we have the waste collection. So we'll be able to locally transform waste into something new with the direct involvement of the local stakeholder. This is just an example of what we are exploring now, but I'm not here to talk to you about the spinning process, but basically we can transform the mass of yarn you can see in the left, on the left, that comes from a frying process into an intermediate material. You can see in the middle picture the sliver, and then finally into a yarn that can be transformed into a fabric, and then the fabric, by the making up process, you can obtain a final product. So this is what we are going to do. As you can see in the sentences, we are not, the innovation of the robot is not the technology itself, because again, we are using technology that already consolidated, but an industrial application. The idea is to optimize, to adjust, to customize this technology, to bring them into a local, decentralized model of circular economy for textile waste. So if we wanted to identify some take-home messages, basically, with Robot, we are and we want to, in the future, demonstrate that a valuable feedstock in terms of textile waste can be identified, can be found also in not so usual scenarios, for example, on the island. That we want to demonstrate that the technology can effectively transform this feedstock, this waste that, I repeat again, at the moment has no value, basically, in something that have a value for the market. And we want to demonstrate that also a small-scale, decentralized, localized, mobile, circular production model is feasible and, of course, can generate value for the supply chain of textile in our case. So that's all from my side, and thank you for your attention. And of course, I am available for the QA session later. Thank you again.
Thank you so much, Omar. Thank you. I won't make more comments because we're running behind time. Let's go straight to Vims, marked Vims, and then colleagues, you'll ask questions at the end of the two presentations. Mark Films is from Comstar. It's also another Horizon Europe project. He's a research associate at Fraunhofer. Please excuse my pronouncement. My pronunciation, sorry. You say it better. Yeah, he holds a Master of Science in Industrial Engineering from Aachen, RWTH, Aachen University, with academic specializations in mechanical engineering as well as textile technologies. Mark, please go ahead and share your screen and do the presentation.
Thanks a lot. Yes, thanks for the introduction. Your pronunciation wasn't as bad. So yes, welcome also everyone from my side. So I have the pleasure today to speak to you on this important matter. The title of my presentation today is called Digital Twins and Circular Manufacturing, the New Standard for Aerospace. So a few words to myself. My name is Mark Willems. I work at the Fraunhofer IPT. IPT stands for Institute for Production Technology. And today I'm here on the behalf of the Comstar project. As you already heard, it's a EU-funded Horizon Europe project. And my focus within that project relies on the development of a recycling technology for these multi-material composite laminates that we're working with. This task is divided into two subtasks. One is this lab scale setup for this recycling approach, and the other is the development of a digital twin for recycled UD tapes. So let me quickly guide you through the agenda of my presentation today. I'll be giving a quick introduction to Fraunhofer Society and the Fraunhofer IPT. Then I'll be speaking about the Comstar project in general, and followed by my specific topic that focuses on the recycling. First, the recycling approach itself, and then the digital twin concept. And then, last but not least, I'll be speaking about the transferability and impact, and also the policy needs of these matters. So, the Fraunhofer IPT works along the full process innovation chain. This includes prototyping and system development. We're specifically focusing on the development of special purpose machinery for the processing of composite parts, including automated fiber placement, also laser-assisted tape winding. And the goal is, as for all Fraunhofer institutes, to bridge the gap from research to an industrial implementation. And this transfer is also essential for circular solutions to actually scale those solutions in practice. So the Comstar project is consisting of a consortium of about 15 participants. It includes 3 universities, a bunch of research institutions, and also a few SMEs and also aerospace companies. So the collective goal of our consortium is, on the one hand, to connect the digital transformation with the sustainability aspect. And that's why this project focuses on advanced composite aerostructure and the supply chains for these structures. Yeah, and that is mainly because there are the most relevant materials that still need development, I would argue. So the wider goal for all of this is to move from a linear to a circular value chain. And doing that in the aviation industry is very difficult because the development cycles within aviation are necessarily very intense, very long, and the qualification of materials is clearly defined, and that is something that is necessary because it's airplanes. So in this project, we're working with so-called fiber reinforced plastics, specifically with carbon fiber composites. And that is important for you to know that these materials are produced by layering fiber tapes that are impregnated with a polymeric matrix. And by this layering process, we produce these composites, and that gives them also their amazing properties. So the core objectives of our project are covering essentially the full life cycle, right? Like from manufacturing to maintenance to repair and then to recycling at the end of life. The project therefore combines zero defect manufacturing with digital twin concepts and sustainable recycling approaches. As said, there is also a smart repair process that is being developed. And the key message is that circularity must actually start at the design phase and not only at the end of life, right? Like circularity is something that we need to consider at the very start of developing products, whatever this product might be. It doesn't make sense to start thinking about how to use the product at the end of life when it actually happened, right? Like when the product has arrived at its end of life, essentially it is too late. And that is something that the development overall needs to address, that something that needs to change, I believe. So here we have a rather large overview of the different developments included within the Comstellar project. We're addressing the full aerospace value chain, and we are connecting essentially the design of aerospace structures with the production of them, the use of these structures, the repair, and then the end of life, where we can potentially recover materials and give these materials a second life. And all of these things are linked with each other by this so-called digital thread, which is essentially a digital research infrastructure. Yeah, you could say it's a database, but it is also capable of more. And the point is that it connects all of these processes. It also links these processes by exchanging data. And it is actually fundamental to allow the traceability of data from the start of a product up to the end of life. And as said, it links materials, data, and also decisions across all stages of the life cycle, and also the value chain. Yeah, so that's the idea. And then I come to the one of our two main topics. So within the project, we are developing a recycling process, a circular recycling process for aerospace grade laminates. And today we have the problem that recycling usually leads to downcycling. So at least in the area of high performance material that we are working with, it is very difficult to reclaim a high performance material out of the products, out of laminates, and usually recycling is connected to a great performance loss. And that is a large problem, because that means high performance materials can only be used once. That's the current state of the art, right? And that is not good. That is not resource efficient. And that is why our approach wants to preserve the tape structure and the material value. And this opens the way for high value reuse and actually multiple life cycles that can be done with one virgin material. So our approach with that was to retrofit a tape laying machine for the recycling functionality. So we took an existing machine and implemented a recycling functionality into that. And the overall benefit of our solution is that we're conserving the tape structure. So we have unidirectionally aligned fibers impregnated with a polymeric matrix. right? The matrix essentially aligns all the fiber, keeps the alignment intact, and it also protects the fibers from like everything that comes from the outside. And we keep all of these properties intact. Impregnation, length of the fiber, all of that is kept intact. State-of-the-art recycling would mean we destroy the product, and then we have short fibers, and well, the high performance thought is gone. What is left is a short fiber that, well, still can do nice nice things, can deliver some degree of performance, but like this very high performance properties are gone with the state-of-the-art recycling. And so with our recycling, we can produce essentially a semi-finished product. So we can reclaim a semi-finished product that we originally used for producing this product. We can reclaim it and make it reusable for the same products. That is the general idea, and that makes this this process recyclable, circular in the original sense. We have already proven that this works for circular specimen. Now we're developing it for flat specimens, so-called laminates, and we aim for 5 to 10% of reduction of the mechanical properties, which would be a really good result. And all of that, to allow a circular usage of recycled UD tapes to perform multiple life cycles at high performance applications. Then the second topic, the digital twin for recycled tape. So one of the problems that evolved around all of these recycling themes is that the recycled materials need trust, like they need to be qualified in some sense. So it's not only the lack of information, but we can make sure that we have more information if we make like the processing history of materials actually accessible. If we implement standards like for the qualification of recycled UD tapes, we enable that these new technologies, these new recycling approaches gain transparency and they gain trust. And making all of that history and uncertain quality and fragmented data, all of that is a challenge. But a solution to all of that is also a digital twin, and that is a concept that has already been proven to be working. There is a bunch of concepts also within the realm of the Industry 4.0 concept, but like it's proven that this concept works and that we can create a traceable record for a recycled tape, for example, right? That also applies to other products for sure. We enable traceability of tape segments, which is a tricky part for us. And we can also create quality data by evaluating, in our case, evaluating the tape thickness, bits, and variation of these matters, and include that into the digital twin. And by that, actually make sure that throughout the life cycle, we can transport the information that are viable and that are important to the materials with the material, right? So this is, as you can see on the right side, you kind of see a data flow chart that I created to display how data can be aggregated and then also used for quality assessment, and theoretically also be redirected back to the recycling process where this data is essentially created. Yeah, as you can see, this concept exists, and a lot of this actually has to do or reminds of a digital product passport, which I have also heard already been spoken about in other presentations. Yeah, and we're also working with stuff like that because data enables transparency and enables trust essentially. So coming to the transferability of these value-retaining thermoplastic tape recycling approach across different sectors, we see that this approach is relevant beyond aerospace. It can support recycling in automotive, in energy, industrial applications. Right, there is a bunch of products that can be recycled by this approach. If we have a look at hydrogen tanks or pressure vessels that are manufactured from thermoplastic tape by tape winding, and have very similar needs regarding the value retention and traceability of tape segments. We can have a look at composite pipes and other tubular structures that are being produced as thermoplastic materials or thermoplastic products in the commercial market already. And also in the automotive industry, we can think of organosheet components that are used within battery cases and produced by thermoforming. Like all of these things can be adapted to, or our process can be adapted to all of these areas and products. And yeah, this strengthens the case for a cross-sector circularity of this approach. Then speaking about the impact of our technology, so actually the impact goes beyond technology, right? Because this also transfers to data, policy, and a general industry resilience. So one of the things that I already mentioned is the traceability, because traceability helps building trust in recycled materials, and people won't use materials that they don't trust, right? Because yeah, it's just natural. So if we see, like if we have a look at this table here in the lower area of the slide, we see like the key contribution of our technology is actually preserving the structure of the tape, and by that also preserving the performance. And that is relevant for the circularity, not only within the EU, but well, in general, worldwide, because it enables high value reuse and it enables multiple life cycles at a high performance level. And that also means we can keep carbon fiber resources within Europe, within wherever you want to keep them, essentially. Then the data concept, the digital twin concept, allowing traceability and quality tracking, builds trust, as just said, and the policies and standards, also some very relevant standards upcoming. We need to realize a harmonized qualification and design for circularity frameworks. And that is very relevant because it accelerates the scale up and the cross-sector adoption of these recycling approaches. And then, last but not least, I'll mention the systemic barriers we have to scale circular composites now, which are like very fundamental linear design, right? Like circular design has not arrived at the very product development stage yet. We have certain regulatory challenges like waste composite products being declared as simple waste, which is not true, right? There is value in this. And we have the problem of fragmented data. So right now, virgin materials often remain much more attractive. They are usually also much cheaper, and their quality can be trusted, right? And I believe policies need to enable the scale by using design for circularity approaches, by using end-of-waste rules and adapting them to the modern standards. I feel like they're kind of a bit left behind in time. We need to realize traceability for materials, and we need to update our standards. And with all of that being said, the EU Circular Economy Act, for example, is being released later this year and is highly anticipated regarding upcoming new regulations for second life materials. And very curious, very much looking forward to that. So this is it from my side. Please follow along. You can scan the QR code or visit our Comstellar project page. Thanks to the organizers and also to the audience.
Thank you so much, Mark, for the great presentation. You know, I was being tempted to just raised my hand. We passed the hour. But
Sorry.
I couldn't bring myself to that. Yeah. So let me quickly just ask as well, Prof. David Olukani, to share some experiences in terms of the projects that he has undertaken at Covenant University and across Africa, just to give you a perspective of what's happening here. So Prof. Olukani is a professor of civil engineering at Covenant University, as I indicated. So colleagues, you probably would have noticed that how interdisciplinary nature the project is. We've got mechanical engineers, chemical engineers, civil engineers, and material scientists as well. So Prof. Olukani, just quickly if we can, and I'll also request at this stage if you could bear with us for the next 10 minutes. We noted that most of you joined a bit late, so please just 10 minutes to allow us to wind up the program, Prof.
Yeah, thank you very much, Professor Innocent, and also appreciating what earlier presenters have done. I think this presentation is a signpost, such like a summary of what the earlier presenters have, made. So you can see here, solid waste management system in transition, the intersection of recycling, environmental sustainability, and the circular economy. Well, the objective of this presentation is basically to sensitize all stakeholders on sustainable waste management strategies. And recycling of waste materials is very key, as earlier presenters have mentioned. We also want to think of how can we promote excellence in waste management by enhancing environmental sustainability for effective waste management, and particularly to promote concept of waste to wealth by way of resource recovery, recycling, and the use of waste materials. And lastly, to encourage the concept of entrepreneurship in waste management. We can identify with this is the urban environmental issues and national developments, which also we have as a cluster. You can see the acceleration of urbanization just continuous every year, severe waste management bottlenecks and urban sanitation infrastructure, defects in urban drainage system, driving widespread seasonal flooding, acute shortfalls in potable water distribution, and particularly anthropogenic degradation, affecting urban air, water, soil, and land health. Well, it's important to also share with us the world cities by population so that we know what are the things we need to attend to. Look at many of the cities here, some of us in Africa, we can see the populations that we are expecting to have by the 2100, which is calling all of us to raise our bar in solving the problem. And this is a key definition for just to also signpost what solid waste management truly is. And it's associated with control of generation, storage, collection, transfer, transportation, processing, and disposal of solid waste in a manner that is in accord with the best principles of public health, economic, engineering, conservation, aesthetic, and effects, and looking also at environmental considerations. It is of interest to know that the global waste management market has been valued as $1.43 trillion in 2024, and is projected to reach $1.97 trillion by 2030. And this market is driven by increasing population, as we all know. And lack of national, regional, and local waste management plans has led to decline in amounts of municipal waste recycled. Well, also towing the line of all my presenters that have presented earlier, you will see that the key challenge is in the processing and the disposal, particularly the critical elements in solid waste management. Generation, no problem. Storage, well, to a large extent. Collection, also in process in many African countries. But how do we process? Because that's actually where the money is. And you can see earlier presenters have spoken so much about the processing before we can think of disposal. It's also important to let us know what is happening in developed and developing countries in terms of waste generation. We have in developed nations 0.70 to 1.20 kg per capita per day, while in developing nations 0.44 to 0.66. So that means the developed nations generate more waste even than the developing one. And the processing of waste is not at its best for resource recovery, particularly in Africa. This is what you might find in some areas in Africa, in Nigeria, particularly, just to let you see the challenge. And many of the things they have communicated to us earlier, some of the waste stream are all found even within all of these components that we have here. Also relating to wood waste, this is construction sites, and you can see waste also generated in form of like steel, all kinds of waste that are generated. But what are the key strategies and opportunities for wealth creation? Recycling and upcycling is very key, important. And we also have to think about waste to energy, then organic waste management, entrepreneurship and job creation, and sustainable construction materials. These are fundamental in order to solve the problem. Noting our title that we are in transition, and there must be concept of recycling, thinking of sustainability, and circular economy. Well, these are some of the things we are doing with our students, projects, particularly trying to generate biogas. And this is actually the flow for that, trying to use cassava peel and many other substrate actual, cow dung, water, palm ash, and thereabouts. You can see we have digested, we have biogas storage, and the gas also to be treated for it to be used either domestically or industrially. And the organic fertilizer also gotten from that can also come to the farmers again to help the soil to get nutrients and produce more useful products. You can see on the bottom side, you can see that big tank and also the gas that has been produced from the project. That is much more also about sustainability as communicated. Well, also we touched base with plastic recycling as well. And you can see on the campus, sensitization is there, collecting all plastic usage on campus. A factory is also situated where all of these are collected and baled, you see, and this is set for industries because there is a collaboration. We have a town and gown collaboration where we have companies and industry who come to the university to collect this and exchange in value for money. And you can see them sorted in green, white, and all of you. Then the organic waste also on the farm also have been applied. And you can see the place of composting as well on the left side. This initiative also has been done in Malawi during one of our projects exchange program, appreciating Professor Teresa, who hosted us at that time. And this is also to advocate for waste to wealth initiative, because these are the young people who also will transit the program and to the society. This also was the societal impact through engagement of secondary school students to let them know that this is what is on the table for them to address, because these are the future, to address the challenge with solid waste management. Well, let me quickly pinpoint the key recommendations. We must prioritize waste prevention and circular design, implement bans on single-use plastics, and target a 50% reduction in landfill waste by 2030 through prevention, reuse, and recycling. And I'm so happy for one of the presenters who talk about digital twins. You can see we must track material flows using digital twins and blockchain. And public reporting on recycling rates and circularity indicators drives accountability and continuous improvement. This is just an excerpt from the major presentation that will be done in the coming week, actually in the public lecture. So I use this opportunity also to invite persons who are here also to join us in the real presentation. Collaboration and projects. We have collaboration with University of Toronto. We have also with North Carolina State University, University of Johannesburg, ASIM Project and Civil Engineering Department here, Adi University, Malawi University of Business and Applied Science, and Liz Beckett's University. Thank you for your audience, and for any inquiry, you can reach me on the emails and also the phone numbers on the screen. Thanks for the organizers and the coordinator of ASIM, Professor Innocent, and also the entire ASIM team, which we are working together on all of this project. That's it for now, minding the time that we have. Thank you for listening.
Thank you so much, Prof, for the presentation, more or less like a wrap-up of what we had, colleagues. We won't have time for an extensive Q&A, but what we can do, Ethel and Stacy, maybe we can do a poll. And just in summary, I think what you have observed and heard from the 4 presentations, how huge the challenge is in terms of waste. And in particular for us, it's wood and other waste materials recovered from construction sites and indeed other waste streams. It is noted that there are several solutions at the moment, but processing remains a key issue. So the new frontier and what our projects that you have heard, especially the 3, is in terms of the technologies that are being used to process these particular waste. So let's hear if there is from the attendees 1 or 2 questions. It's 11 minutes past 2. I did ask for 10 more minutes, so we can allow 1 or 2 questions from the audience, the attendees. Any questions, you can raise your hand and the colleagues will assist us. Or if you just want to make a comment in terms of what has been presented. We're so sorry that we ran out of time. But any comments or questions? Uratile Mutaung, you can go ahead, Uratile. Go ahead, you can ask your question, Uratile. We can't hear you, Uratile. Or do you want to type the question or comment in the chat there, perhaps, while we're trying to sort out technology? Any other hand or question? So let me go first. Just one question. So what we had an advancement of various recycling and upcycling technologies. I just want to find out from any of you the merits of advanced recycling and upcycling technologies. And these are often discussed in terms of environmental and climate gains. In your opinion, what are the social, economic, and cultural, if any, gains should the industries anticipate when transitioning to these technologies? I think we're also trying to weigh the cost of technologies in place. And anyone could respond to this question.
If I can,
yes, someone go ahead. Yes.
Thank you very much. As you said, we often talk about the benefits that we have by implementing recovering or recycling of waste in terms of environmental impacts. But I think that we will have impacts also from an economic and social point of view. In particular, if you imagine when the technological approach, so the process, the logistic will be optimized and consolidated and structurally included in the current business model. In that case, we will have also probably a reduction in terms of cost in processing, in material, in products, because often, at least in the textile sector, of course, I'm talking about textile sector, the recycled materials and product finally have an higher cost in comparison with the traditional virgin one. And so we need to push on the integration and consolidation, not only from a technological point of view, but also from a sort of legislative point of view, how we can consolidate this new potential circular approach. And the consequence is that recycling of textile waste, in our case, will be more and more feasible. The overall cost will reduce, and then we will have more products on the market. And if it will be well communicated to the final user, so to the customer, maybe also we will have a sort of shift in their mindset. And so we will also have an impact on the social habits in terms of which kind of products the consumer is let me say, is happy to buy in very simple words.
Okay, thanks, Omar. Anyone would like to add? Let's hear from Hope. Stacey, go ahead.
Thanks very much, Prof. Musonda. Omar, I just wanted to ask a follow-up question. I see that you guys have been doing a lot of work with stakeholders there in the island communities. And related to your response that you've just given, how has been the reception? Have you seen some evidence that mindsets are changing around recycled products? Is there some enthusiasm from the communities? I'd love to hear the reception from the public.
Yeah. Thanks for the question. To be honest, Rebot is still in the more or less middle of its life, let me say. So we didn't start yet with the pilots, and so with the direct involvement of the local stakeholders. But what I can say you, because we collaborating with another project that is close to its end, that is very similar in terms of approach, because we have in the other project we are not partners, but we collaborate with them. They already have that sort of pilots, and they I can see from their experience that there is a lack of awareness, of knowledge from the let me say, from the citizen also, for the viability of these new materials and products. There are people that, okay, I know that potential, I know that I can buy something that is coming from recycling, but in most of cases, there is still a sort of lack of knowledge and awareness about that potential. And what this project taught us is that it's important to start with the new generation, with the young guys, to make them understand the potential of this change in terms of purchasing habits. So this is what I can say.
Thank you so much.
Thanks, Stacey, and thank you, Omar, for that. I'd love Mark to make a comment on this, because Mark, you highlighted the issue of trust in terms of how huge a challenge is that at the moment?
So first of all, I agree with everything being said so far. Shift in mindset is also a good point to speak about. Like in general, like materials that like achieve their end of life don't need to be viewed as waste. They need to be viewed as like valuable material assets. And like if we manage to use recycling approaches that keep value intact, I think that's the point. We need to make sure that that we're preserving value by using circular principles, and that will actually lead to like a strengthening of our economy and well, everything we do. I believe so.
Fantastic. Thank you so much. I had to bring this webinar to an end.
There was a question asked, Prof.
Yes,
okay.
I see there is one. Maybe you're going to respond to this particular question by Nomfundo. Are you sharing the screen, Prof?
Yes, just
ahead.
a quick one to speak to this. I saw a question online that talks about what is happening in the coming week. And I'm just glad to let you know that what I've presented today is just a tip out of other things that will be coming on Wednesday, the 5th of August, 2026, 1:30 to 3 p.m. And everyone on this platform now are invited. The link will be shared with each and every one of us to be part of that. It's going to be both virtual and also on site at the JBS. All the details as you have on the screen. Yeah. So looking forward to having you around. Thank you very much, Prof.
Thanks so much. Colleagues, unfortunately, we have to end here, but you did hear from the presenters, we ran out of time, and the stories and the lessons learned from the different projects obviously were there for us to see, and there's one goal. It's a realization that advanced recycling and upcycling technologies, obviously at the moment, they are unlocking new secondary materials. You heard that there are issues of trust, there are issues of awareness, and unlocking the real value thereof. And so when it comes to processing, that's where we are now spending more time to achieve those. Please look out for the next webinars, including the lecture that will be presented here at the University of Johannesburg next week. But look out for more webinars on different streams, including the follow-up. We did share the contact details. Please send your questions. We will respond to you. And the conversation on Discord, for those that have got an account on Discord, it can also, continues going forward. Thank you very much. Over to you, Ethel, and the team. Thank you very much. I appreciate Omar, appreciate Mark, Jaime, and Prof. Holukani for spending your time with us, and the colleagues who are in the background preparing for this, more especially Iswa, as well, headed by Abby, in terms of this webinar. Thank you very much.
Thank you very much. Thank you very much, everybody.
Thanks a lot.
Thank you very much for the invitation. Nice meeting you, Mark, Omar, and Belza.
Very much.
Thank you. Thank you very much.
Thank you all.
Thank you.
Cheers. Bye-bye.
Thank you all. Thanks. Bye-bye.
Bye-bye.
Thank you.
Bye.
Thank you.
Bye.
Thank you.
Done. Quick meetings. These meetings, they'll kill us.